Let's now learn graphing the solution of a system of linear inequalities. And before we really get into this lesson here, then it is required that you need to know how to graph the solution of one single linear inequality, because what we're doing here now, we are going to graph the solution of a system of more than one linear inequalities. So make sure you know how to graph the solution of one linear inequality. And I've had other video lessons on how to graph the solution of one single linear inequality. So as an example, let's graph the solution of the system x plus 7y less than or equal to 42. And in the same system, we have a different inequality, 5x plus y less than or equal to 40. And we have a third inequality, x is greater than or equal to 0, and y is greater than or equal to 0. And so as I said earlier, it is required that anyone viewing this video must know how to solve how to graph the solution to any of these single inequality as a linear inequality with two variables. So our first inequality, x plus 7y less than or equals to 42. In my own approach here, and of course anyone viewing this video should also be able to do that in any other approach, as long as you have your graphed solutions being shaded correctly. But so I use this approach where I'm going to turn my equation as I'm going to turn my inequality into the equivalent form y is less than or equals to negative 17 x plus 6. And you can pause the video or feel free to pause the video at any time to make sure I did my algebra correctly to rearrange this inequality into the equivalence inequality, but now displaying the slope intercept. And so here what I'm looking at now is a line with intercept at 6. So I have the x-intercept, I have the y-intercept at 6, which is here. But unfortunately, the viewing window in my graphing space is not far enough to show my x-intercept. So but with the slope information here is enough for me to show my line within this space right here. So the slope is indicating I'm gonna drop 1 and run over by 7. So drop 1, decrease 1, but runs by 7. So that means I'm gonna drop another point here. And so now I'm going to go ahead and connect the points. And so with straight edge and ruler, I can now make the graph for our current line. Either we can read that as the line x plus 7y equals 42, or in slope intercept, y equals negative 17x plus 6. So here's the line right here. And so I have to clarify one thing, that on the graphing space I'm currently using for this problem, then each square unit right here on the vertical line is a 1, and the horizontal space here is also a 1 as well. And so that means the y-intercept right here on this current line we already found is at coordinates 0, 6. And I also have mentioned briefly in here, this line in particular, either form of how we have written it, but this line has two intercepts. The x-intercept is at 42, 0. This is the x-intercept for this current line we just obtained. And on the other hand, the y-intercept is being displayed on the graph itself, 0, 6. This is the y-intercept. And allow me to go brief on how to obtain this. And as a matter of fact, I skipped the steps showing how to find this, because I'm assuming you've learned these skills from other video lessons. And since the x-intercept has the x coordinates being quite far beyond our viewing window here of this graph, and it's only a handmade sketch right here, so I'm not going to be able to display the x-intercept, but that's not quite important. We already had the y-intercept of this current line, of this current graph here, and then we dropped another point to satisfy the slope being negative 1,7, and so here we have successfully graphed our line. Either you can read x plus 7y equals 42, or y equals negative 17x plus 6. But now remind yourself in the end that what we're looking for is the solution of this inequality. So now when we are truly looking at this as an inequality, so notice the inequality sign here comes with the equal sign. So that's the reason why I was drawing and graphing my line here as a solid line. But now we are going to really indicate the region that satisfies this inequality. We need to start shading, but here being less than, so we're going to be shading below this line. But you see how deciding how to shade below or above, once again, it all comes back to the requiring that you need to view a different video so that I can explain in details how we can find the graphical solution successfully. And now for our other inequality, let's look at 5x plus y being less than or equals to 40. I can see this line here as the line y less than or equals to minus 5x plus 40. This line allowed me to skip the algebra step in this example, but this line will have two intercepts. The x-intercept is at 8, 0. And so this is the x-intercept. And the y-intercept of this line is at 0, 40. So the y-intercept for this line is way outside of our viewing window, making it impossible to draw the intercept, but we can still have that other intercept, the x-intercept, being displayed right here in our system right here. So we can display this x-intercept right in our graphing system. So 8, 0 is this point right here. So this is the x-intercept of our line. Either you can read that as 5x plus y less than or equals 40, or y equals minus 5x plus 40. And then once again, in this case, I would say this form, the slope-intercept form, gives me a little more advantage, simply because I already had one point. So all I need to do now is to drop another point so that it shows slope being negative. Now remind yourself that slope negative means we're gonna the relationship between the 2 points have to be a dropping from the left to the right. We drop 5 and over by 1. So it's, if you're looking at these 2 points right here, it just happened to be the way it is. Doesn't always have to be like that. But this point right here happens, the point that I used previously for getting the other line. But now this point also happened to be the line where it makes a slope negative 5 from this point to this x-intercept right here. And once again, after using straight edge and ruler, here's the graph for my line 5x plus y equals 40, or a different way of reading it, y equals minus 5x plus 40. And so let's now quickly make a label right here. But this line here is the line x plus 7y equals 42. This other line here is the line, the equation for that, 5x plus y equals 40. So now this new line, or the second line we just put up right here, the inequality now says we need 5x plus y is less than or equal to 40, and then in the easier form to recognize y must be less than or equals minus 5x plus 40. So the line here is minus 5x plus 40 to equals y, but we need y also to be less than the expression minus 5x plus 40. So here I'm going to be shading, and in a different direction of shading, I'm going to be shading horizontally like this. And so now anyone viewing this video is going to start seeing some double shading between the two regions already. And this line 5x plus y equals 40, and the other line that we graphed previously, x plus 7y equals 42, has an intersection right here, and we will find that out later. And once again, this line here needs to be a solid line due to the fact that the inequality came with the equal sign. And so now allow me to erase out some minor details right here. But now after this graphing the solution of the two inequalities here simultaneously, and what we can recognize here is a double shaded region here, then our system from the beginning had a third requirement that the x values must be greater than or equal to 0. So as a line, x equals 0 is a vertical line right on the y-axis. So the y-axis itself is the line x equals 0. So now to make a shade, to make a shade that satisfies x greater than or equal to 0, and of course we're including the line again, I am going to use in blue marker a shading that stays to the right hand side. Of the graph. And of course it's just the way it is, that when we have a lot of shadings being blended together, then the picture is starting to become a little hard to recognize. But it seems like this area where my finger tip is tracing is where it satisfies, it has the blue and mixed with the double shaded regions. Out here it's only double shaded black region. Up here it's only one way of the black and interfering with the blue. So only inside of this line. This is our line right here. Okay. And so the region here satisfy three requirements. Last requirement to put in is the requirement saying that our y variable has to be greater than or equal to 0. So the line y equals 0 is the x-axis. So the x-axis is a different name of the line y equals 0. And we want to be greater than or equal to 0. And the inequality has equal sign included. And so that means I'm going to make a shading, but I'm including the line itself here. So my line has to be remains a solid line. And so this time I am going to make a shading above the x-axis. And so now, after putting it all together, the region we really are looking at, where it satisfies all four inequalities here, is this region. So this region right in here. We have a corner point right there. These points are called the corner points, where the lines intersect with each other. Because this region, if we have a closer look, I hope I can zoom it in any better, but if we're looking at that, it has the blue, it has the red shading, it has the double black shading is all being in there. There's a black going this way and there's the black shading going that way, so it has all four requirements being inside of that. But we're not quite done. We're 75% of the work being done here, but we need to figure out the actual coordinates of all these vertices on our region. So now at this point, I have to make sure, I have to clarify that we have already found the region, but we need to be specific about what these corner points are. So just the way how it looks, then these are naturally the 4 corner points. And these 3 corner points are already quite easy. This point came out from the y-intercept of our equation here, and we already knew that was 0, 6. So not much to worry about that. This point is nothing but just the origin, so 0, 0 has to be the value. So it could be getting a little too much blended in one picture over here. And this other point is indeed the x-intercept with coordinates 8, 0 from our line 5x plus y equals 40. And so the last thing now is to find out what this point is, the intersection between. So what is this point? This point is the intersection between the two lines x plus 7y equals 42 and 5x plus y equals 40. And so finding the x and y value that's being the intersection of the two lines previously seen in the graph, and allow me to put the graph away because we need space here, but finding that value being the x and being the intersection of the two lines previously, that point, that coordinates pair, is simply just the solution to the system x plus 7y equals 42. And the other equation was 5x plus y equals 40. So once again, my point is the intersection of the two lines that we saw previously in the graph, expressed as a pair of value x and y. That pair of value x and y is simply just the solution to this system of two linear equations. And we have spent some time learning about how to solve for a system of linear equations. I just simply need to remind that anyone who is about to solve this system of equation, you have 3 different choices. Either you can solve by substitution method, or you can solve this system of linear equations by the elimination method. And for anybody else who attempt to use the matrix, where eventually calculator can handle that for us, then the matrix is set up as 1, 5 as one column, 7, 1 as another column, a vertical line for the equal signs, 42 and 40 as a third column. And what we have here is, remind yourself, it's an augmented matrix, where the learning material about this has been quite recent for us. And so taking any of your preferred method to solve for this system of equation, either by using an augmented matrix, or with assistance from the calculator, or solving it by hand using substitution method, or using the elimination method, answer finally comes out to be x equals 7 and y equals 5. And that is this point here is one of our corner points there. All right, so now putting it all together on this graph right here, we have this last corner point that we were making so much steps to solve for, and it's the way it is a lot of times. So this corner point is happening at coordinates 7 for x, 5 for y, or for short, 7, 5. So now we have found the region being the solution of the 4 inequalities. This region right here is, in other words, the solution, the graphical solution, the graphed solution of the system of 4 linear inequalities of 2 variables. So x plus 7 less than or equals to 42, and simultaneously needs to be 5x plus y less than or equals 40, and also satisfy x greater than or equal to 0 and y greater than or equal to 0 as well. So immediately before we leave this example and completely be done with that, the solution here later on in your study, when we start applying the concept of graph solutions of an inequality, of a system of linear inequalities into when we apply that skill and apply this region into a problem to find maximum and minimum value problem, then a region like this has a new name. So right now, purely in this example, I only want to regard to this region here as the solution to our system simultaneously that satisfy 4 inequalities here. But as I said just right now, that to prepare anyone viewing this video for a later application, very powerful application, then this region, when we apply that into a maximum and minimum problem, then this region is regarded to as the feasible region. The reason that it's quite important to mention this terminology here is because the biggest motivation to solve a system of linear inequality like this is to bring that region of our solution into solving a maximum or minimum value problem that we will later on learn. And so for that reason, when we're in that kind of problem and apply our region of solution to the system here into solving a maximum minimum problem, that same region there has a new name, and we call it it's a feasible region.